Hello students, I am Dr. Gajendra Purohit. You are watching YouTube channel where we upload videos for engineering, mathematics and B.Sc. If you are preparing for any competitive exam where higher mathematics is asked, it will be very helpful. Today, I will be presenting to you new test of infinite series 2.0 which is called Logarithmic Test. I am going to cover that in today's class, and the tests that I will cover under this series are somehow related to particular conditions. I am trying to tell that if the D'Alembert ratio test fails, then we are left with two options, either Rabe test or a logarithmic test. I have already explained Rabe test in the previous video. You can go and check it out from IIT-JAM. Now you might be wondering, when do we use the logarithmic test? Students, we use the logarithmic test when we have any nth term in the power or in the factorial form, right? If the nth term is in power or if the nth term is in form of the factorial and the D'Alembert ratio test is failing, then in that case, we use the logarithmic test. But students, this test also fails under particular conditions. If it happens to fail by chance, then we use a second logarithmic test there. You might question that if Rabe test fails, what should be used then? In that case, we apply De Morgan's test. Clear? So, you have to figure out which test needs to be applied and when it is to be applied. If the test is failing, then how you have to move ahead, right? So, today we are going to learn about logarithmic test. We will also see what are its conditions for convergence and divergence. Let's discuss about logarithmic test now. Let's suppose we are given here any infinite series where all the terms are non-negative. In this infinite series, if we are given limit n tends to infinity n log un upon un plus 1 is greater than 1, where un is the nth term of the series. If its value is greater than 1, in that case, this series will be convergent. And if its value is less than 1, then it will be divergent. And if it becomes equal to 1, then the test fails. For that situation, we will have to use the second logarithmic test, which I will explain in my next video to you. Let's take an example. But I want to tell you something before that. We apply it when the D'Alembert ratio test fails. This is important to note. So students, let's discuss this now. We have an infinite series given here, and you need to determine the condition under which this series will be convergent. What will we do first? We'll find nth term for this. Here it's coming 1 and 2 and 3. Value of nth term is coming as n to the power n. X to the power of n divided by n factorial. So this will be our nth term. What will we do after this? What will be our un? We are getting our un as n to the power of n, x to the power of n divided by n factorial. In this, if we discuss un plus 1, then we will get it as n plus 1 raised to the power of n. We will get x raised to the power of n plus 1 divided by factorial of n plus 1, right? To this, we will apply D'Alembert ratio test. In the D'Alembert ratio test, limit n tends to infinity. Now, when we will divide un plus 1 by un, it will give us limit n tends to infinity. So students, this un plus 1 will be equal to n plus 1 raised to the power of n plus 1 and x raised to the power n plus 1 upon n plus 1 factorial. Now, upon un will be n to the power of n, x to the power of n, and put n factorial above it. Let's simplify it. Look, here we have n plus 1 to the power n plus 1. Okay students, this has been given here. If I want to write it, I can write it like limit n tends to infinity n plus 1 into n plus 1 raised to the power n. Clear? X will cancel x, so put x on top. N factorial term will be same. Upon n plus 1 factorial, written as n plus 1 multiply by n factorial, and n power n will come. N factorial will cancel n factorial, n plus 1 will cancel n plus 1. If we divide this by n power n, we will get the value as limit n tends to infinity. Then the value we get is 1 plus 1 by n power n, because we are dividing this by n power n. It will be into x. And now when we put limit n tends to infinity, then the value here will be ex. All of us are aware that whenever ex is less than 1, meaning if its value is less than 1, then by D'Alembert ratio test, series is convergent. If you haven't seen my video on D'Alembert ratio test yet, the video is there on the IIT-JAM. You can check it by going to the IIT-JAM. This means that if x is less than 1 upon e, then what will we call it? It will be convergent. If the value of x is greater than 1, meaning greater than 1 by e, then in that case, what will happen to it? It will be divergent. If the value of x is equal to 1 by e, then in that case, our test fails. And when the test fails, what do we do after that? What happens? Tell me students. We will use the logarithmic test. Now we have this logarithmic test here, right? What does this test do for us? It tells us the value. we need to find value of the limit n tends to infinity. In this, we will get n log un divided by un plus 1. Here we have un plus 1 divided by un. What is this value for? First, let's invert this un plus 1 upon un. And when you invert it, we will get 1 upon, meaning 1 becomes numerator. Because ultimately, when all of this cancels out here, we will get 1 divided by 1 plus 1 upon n raised to the power of n. And in this, we are substituting this x with 1 upon e. So, when we will flip this x, meaning we will write 1 upon e here, this e will go to the top and become numerator. This will be the value we will get, right? Now, what will we do here? We will apply the concept of log a upon b to it. Then we will get limit n tends to infinity. We will get n here, and this we will be getting it as log e minus log 1 plus 1 divided by n raised to the power of n. Right, students? This will be the value we will get. Now, all of us know the value of this log e. What will it come out as? It will be 1. So, we will get its value as limit n tends to infinity. We will put n here, and this will be 1 minus. Let's take out this n, and we will get n log 1 plus 1 upon n is the term we will get for this. Students, you should know the series of log 1 plus x to solve this. So, I am going to write down the series for log 1 plus x. The series of log 1 plus x will be written like this. X minus x square upon 2 plus x cube upon 3 minus so on. It goes on like this. So, this is how the series for log 1 plus x is formed. We will apply this series here. The value of 1 plus x is 1 divided by n here. So, when we will apply this here, we will get limit n tends to infinity. We will get n then 1 minus. And when we write the series here, it will be written like this, 1 divided by n minus. And what will we write after that? Here we will write 1 divided by n whole square, 1 divided by 2 and plus 1 divided by n whole cube and 1 by 3. This is how the series will be formed. Let me change its color a little bit, it will look better. So students, in this manner, it will go on, right? Hence, this term will continue in this way and this n is lying outside of it. This is an important thing to note, okay? Next, we will multiply this n. From here, what will the value come as? We will get its value as limit n tends to infinity. Keep this n outside. Write 1, then cancel this n with n. We will get minus 1. Minus minus is plus and we will get 1 by 2. This n square will be cancelled by this n. We will get 1 by 2n. We are getting 1 divided by cube of n and then we are getting minus 1 divided by 3. This will be n square. In this way, we will get the term for this. Now, you can clearly see that 1 is cancelling 1 here. We will keep this n inside as well. When it goes inside, then we will get limit n tends to infinity. Okay? From here, we get 1 divided by 2 because n cancels out n. Minus 1 divided by 3. N will come here. It will go on like this when we put n tends to infinity. Students, as soon as we will put n tends to infinity, this term and all the terms further ahead will become 0. From here, we will get the value of this as 1 divided by 2. And 1 divided by 2 means it is smaller than 1. Normally, it's larger than 1. In that case, it is convergent. But in this case, we are getting it smaller than 1. This value is coming smaller than 1. Therefore, if we apply the logarithmic test to this series, then it will come out to be divergent when value of x equals to 1 divided by e, right? This means that if I want to talk about x here, what will we find? What happens with this x? We will see that. If the value of x is less than or equal to 1 divided by e, then this will be convergent. And what do we say if the value of x is greater than 1 divided by e? It will be divergent. Right, students? You need to pay attention to this. We will solve this question in this way. You can see the solution here. Now, in next question, what are you asked to do? We are asked to test the convergence of the series in this question. What will we do here? First, we will write the nth term. Here, we have nth term, so it will be written as n. And here we have 1, then we have 2. The power of this will come out as n minus 1. And we are given 1 factorial, 2 factorial, 3 factorial here. So, 1 less factorial will be n minus 1 factorial. And we will get the power of x as n minus 1 here, right? So, students, we will get this as our nth term here. Meaning that we will get our un as n minus 1 factorial into x raised to the power of n minus 1 upon n raised to the power n minus 1. Right, students? Similarly, if we write un plus 1, we will get it as n factorial x raised to the power of n divided by n plus 1 raised to the power of n. Now what will we do? We will apply D'Alembert ratio test. On applying this test, we will get limit n tends to infinity. We will find the value of un plus 1 upon un. This will be limit n tends to infinity. What will we do? We will put un plus 1 here. So, we will get it as n factorial x power n upon n plus 1 power n. This is our un plus 1. Un will go in the denominator. Its value is coming as n minus 1 factorial x power n minus 1. Its denominator, so inverse it and take it above. I wrote it like this. Let's simplify this a bit. On simplifying, we will get limit n tends to infinity. We will take this n factorial and write it as n multiplied by n minus 1 factorial. This x cancels out with this x. First, write this n power n minus 1 here and we will be left with x divided by n plus 1 raised to the power of n. So, I am going to write it as n plus 1 and here I will write n plus 1 raised to the power of n minus 1. So, we will get n minus 1 factorial. This will get cancelled with this. We took 1 out of n plus 1 power n and wrote it like this after reducing the power by 1. We did this because we are trying to simplify this. If you don't want to do this, that's also fine. If you think it's not necessary, don't do it. You can leave that. You can also simply write it as n plus 1 raised to the power of n. This n will be multiplied by it. We will get it as limit n tends to infinity. It will come as n power n. I will take this n raised to the power of n up here and then I will take this n common here. We'll get 1 plus 1 by n whole power n. This n power n is cancelled by n power n. When we keep n tends to infinity, this will become e. From here, we will have the value as x divided by e. And we know that when its value is less than 1, meaning if we talk about the condition when it is convergent. When is it convergent? Pay attention, because if this value is less than 1 and this value is coming as x by e, which is less than 1, it implies it is going to be convergent as x is less than e. Now coming to divergent. So students, when will it be divergent? We will get the series as divergent when this x is greater than e. But this test fails under certain conditions. So when will this test fail? This test will fail when x is equal to e. Now when x is equal to e, then which test we will use? We will use logarithmic test. When this logarithmic test is used, then we will get limit n tends to infinity. This will be n log. What will be the value of un upon un plus 1? We will check if its value at n tends to infinity is greater than 1 or less than 1. Now we will find out this. What will we get then? Here we have limit n tends to infinity, n log. We have this value here. If you look at this value, which is x upon 1 plus 1 divided by n whole to the power n, this is un plus 1 upon un, and here it is its inverse. Inverse means this will go up and x will come in the denominator. Put e in place of x. So students, when it will go up, then it will come to us as 1 plus 1 by n whole raised to the power of n divided by e. I hope you remember this from before. This will go up and x will come down. In place of x, we have to put e. This has to be understood. We get limit n tends to infinity. This will be n, but first I will separate this. So here we will get log 1 plus 1 by n raised to the power of n minus, and this will come as log e. Let me change the color so that it looks a little better. We will get limit n tends to infinity. So this is what we will get. So from here we will take out n. Then log of 1 plus 1 divided by n will be the value that comes. And from here we will have value of the log e as 1. I had told you the series of log 1 plus x just now. What was it? We will get it as limit n tends to infinity. Then n. See, this is n and its series will be formed as 1 divided by n minus 1 divided by 2 into whole square of 1 divided by n plus 1 by 3 into whole cube of 1 by n. This is how our series will be formed. We will put minus 1 here. This n will be multiplied inside. The value will come as limit n tends to infinity. We will write n. N will go inside and we will get minus in 1 upon n. N will be cancelled by n. We will get 1 by 2n. So we will get 1 divided by 2n because n will cancel n. This will be 1 by 3n square because n is cancelling n here too, right? So this is how it will be formed. We are left with this minus 1. What will happen to this? 1 will be cancelled by 1. Now take this n inside. We will get limit n tends to infinity. Now when we take this inside, this will come minus 1 by 2. When this n will go, we get 1 by 3n. This is how we will get its value. As soon as we put n tends to infinity, then this will be 0. What will happen to all the terms ahead? The terms ahead will become 0. From here, the value we have will be 1 by 2 and it is coming in negative. So it will be smaller than 1, right? This means the series will be divergent. If you are being asked when will it be divergent and when will it be convergent, your answer should be when x is less than e, it will be convergent. And it will be divergent when the value of x is e or greater than e. So even at x equal to e, it is divergent. If you are ever asked the reason, this is the way to do it. Let's see the next question. In our next question, we are given 1 plus 2x divided by 2 factorial, 3 square x square upon 3 factorial, and it continues in the same pattern. If we discuss about the nth term of this, we have 2 at the bottom. We will get it as n factorial here, right? And students, since this is coming as 2, so this will also be n. And as the power is 1 lesser, so we will get the power as n minus 1. And x raised to the power of n minus 1. This will be the nth term. Clear? Now, if we look at un plus 1, then we will get it as n plus 1 raised to the power n, x raised to the power n. In the denominator, we will write n plus 1 factorial. Clear? What will we do here? We will apply D'Alembert ratio test to it. So, limit n tends to infinity. We will take un plus 1 upon un. It will come as limit n tends to infinity. So, we will get n plus 1 to the power n into x to the power n upon n plus 1 factorial. Put this term in denominator. We will get n power n minus 1, x power n minus 1, and this n factorial, which was denominator, will become numerator. Let's simplify this. Then we will get limit n tends to infinity. We can see that we have this n plus 1 given here. So let's leave it as n plus 1 raised to the power of n only. This x will get cancelled. So n factorial should be put here and then x will come here. We had n plus 1 factorial here, so I will put n plus 1 and we will get this n factorial. This will be n power n minus 1, n factorial and n factorial are cancelling each other. We are left with n plus 1 and this term is also getting cancelled. So limit n tends to infinity. We can see that when n plus 1 is cancelled, we will get n plus 1 raised to the power of n minus 1 divided by n minus 1 multiplied by x. What should be our next step? We will take this n in common. Once we do that, we will get limit n tends to infinity. This will come as n power n minus 1 into 1 plus 1 by n power n minus 1 into x. Divided by n power n minus 1. This term cancels this term. We know the value of this is e and this will be x. Therefore, we get the value of this as ex. We know the conditions under which this is convergent. Right, students? Do you remember those conditions? It is convergent when the value of this is smaller than 1. That means we have ex less than 1. It implies that the value of x is less than 1 by e. Now, under which conditions does it become divergent? It is divergent when x is greater than 1 upon e. This is just the opposite of former. So, students, under which condition will the test fail here? When does it happen? All of us know that the test will fail in the case when the x is equal to 1 by e, right? Our next step is to apply the logarithmic test to it. In this we have limit n tends to infinity. We will write n log. After that, we will put the value as un divided by un plus 1. Our next move will be to calculate this here and find out the exact value of this term. So, when we calculate its value, it will come out to be limit n tends to infinity. It will be n log. We are getting this as un plus 1 by un. We will reverse this and put it here. Means the value will be reversed and put here. So students, here we will get it as n raised to the power of n minus 1 divided by n plus 1 raised to the power of n minus 1. Here we will put the value of x as 1 upon e because this will be inverted and x will go in denominator. 1 upon e will go in the numerator. Right, students? You need to keep this in mind. Then we will get the value of this as limit n tends to infinity. From here, what are we getting? First of all, write log here. And this is what we are getting. So students, we will write 1 upon. When I take this n in common, I will get 1 plus 1 upon n whole raised to the power of n minus 1, right? And we have this e in the numerator. We will let it remain here only. So the value we get will be limit n tends to infinity. The value we will get from this will be n followed by log e minus. From here, we have its value as log 1 plus 1 divided by n whole raised to the power of n minus 1. What should we do after this, students? What will happen next? We will get the value of log e as 1. Therefore, at n tends to infinity, the value we will get is 1. And we will take out this n minus 1 given here, and this will come as log 1 plus 1 divided by n. Now we will expand this series. So students, when we expand this series, we will get limit n tends to infinity. And then write n, then we will put 1 minus, followed by n minus 1. When we expand the series given here, we will get the value as 1 upon n minus 1 upon 2 into whole square of 1 by n plus 1 divided by 3 multiplied by whole cube of 1 by n. So this is the value we get after expanding it. Our next step is to simplify it. We get limit n tends to infinity. This n will remain as it is. We will take this inside. Hence, we get the value as 1 minus. When we take this n minus 1 inside and multiply it with every term, we will get n minus 1 divided by n minus 1 divided by 2. And then we will get n minus 1 upon n square. We will get rest of the terms in this pattern. Let's divide this n separately with each term. When we divide it with this, we will have 1 cancelling this 1. So students, we will proceed from here. I will erase this part. So the value we will get after doing that will be limit n tends to infinity. On calculating its value, we will get n as it is. So, students, when we cancel this n by n, we will get 1 minus 1, and this will come as plus 1 divided by n, followed by minus 1 upon 2. And when we do this here, it will be n minus 1 upon n square. In this pattern, we will get rest of its terms. Here you can see this one is being cancelled out. Now, we will take this n inside. The value we get is limit n tends to infinity. When this n goes inside, we will get 1 here. And when we multiply this n with the next term, we will have minus 1 by 2 into n square minus n upon n square. Rest of the series will be formed like this. So students, you'll see when we put n tends to infinity, we will take out n square common here. This n square will also be common, so take it out. From here, the value we get will be minus 1 upon 2 and 1. So the value will be equal to 1 by 2. We have a correction. When it goes inside, it will become plus, right? The term which we will get will also be a positive term. So this will become a positive term, and when we put n tends to infinity, what happens? From this, we will get 1 here. And when we take out this n square as common, the value we will get is 1 divided by 2. Therefore, its value will be 3 upon 2, which is greater than 1. And whenever it is greater than 1, the series is convergent, right? I had explained that a series is convergent when the x is less than 1 by e. But it is also coming out as convergent when they are equal. So we will make equal sign. And then what did we have here? It was coming to be divergent. So in this way, we can easily solve this type of question. So students, this question is for the comment box. Please be sure to let me know how long it took for you to solve it by commenting. More videos of 2.0 and the entire series is available. If you are preparing for CSIR, NET, GATE and IIT-JAM and want to strengthen your concepts and master your tricks, you can check out the playlist by going here, and please subscribe to the channel as well. Thank you very much. Bye-bye.